Let's discuss couple of properties of union of sets. Okay, so we'll discuss about the properties. Now, in properties, the first one, very important one, is the commutative property. So, in the first one, we'll talk about commutative. So, commutative, you guys know what is commutative. That means here we have A union B is equal to B union A. And I think it's quite obvious to understand why it is true. Because see, the elements in A and elements in B, you're combining together. That's basically union, correct? It's like in the sense, suppose if you have, let's say, A is 1, 2, 3, and say B is 4, 5, 6. See, when you do A union B, this becomes 1, 2, 3, 4, 5, 6. And when you do B union A, you are going to get the same thing. 1, 2, 3, 4, 5, 6. Both A union B, B union A, you're going to get the same thing. That's why union of two sets is commutative. Okay, same way, the second one is associative. Okay, associative law. In the sense here, when you have A union B union C, this is equal to A union of B union C. It's same as commutative, but associative, correct? So the same logic what we used for commutative, we can use it for associative also. Take A, B, C as three sets, do the union, you're going to get the same thing. Okay, so the first two laws. Now the third law or third property you can call it, is the existence of identity. So in the sense here, the third one is the existence of identity. See, whenever we talk about identity, meaning what? Let's take an example of additive identity. The number plus the identity gives the number back, correct? Or multiplicative identity. So that means here, when you do union of the set with the identity set, or whatever you call it, that should give me the same set back, correct? To be very, very specific, it should be the same set back. So here, suppose if A is the set. So here, when you have A, when I do union with something should give the same set back, correct? Same thing. I cannot take again A itself, A union A is equal to A, that comes later. Okay, we have a law, but that's not the identity. That means that element, or you can say the set, has to be a null set. Okay, that means the law or the third property becomes A union phi is equal to A. So the existence of identity. Okay, this is the third property of union of sets. The fourth property, this is a very very important one. Also, we use it in quite a lot of problems. So this one is called as the idempotent law, or you can say idempotent property. Now this, what it tells you is that A union A is equal to A. When you take the union of itself, the answer is going to be the same set. So this is A union A is equal to A. Fair enough? The next one, the next law, or you can say the next property, is that the next law talks about the union of the universal set and the set itself. Okay, so you can say it's just, there is no name as such for this particular law or particular property. We just call it as, suppose if you have A union the universal set U. Okay, so this value becomes 8. This value becomes U. Okay, so this is the fifth one. So basically you have 5 properties of union: commutative, associative, Third one is the identity. Identity is nothing but the null set or the empty set. The next one is the idempotent law. A union A is A itself. Then the last one is, suppose if you take the set and the universal set, when you do the union, you're going to get the value of U, the universal set. All right. So these are the 5 properties of union of sets.